Okay, guys, we're going to start the differentiation today. There is a part of the mathematics, a section of mathematics known as calculus. Okay, and there are two sections of calculus. One is the differentiation, okay, and the other is integration, and these are the opposites of each other. Okay, so we are going to start from the differentiation today. There are some techniques of differentiation. Right now I'll not be telling you guys that why do we differentiate, how it is done. You only need to grasp the techniques of differentiation first, and then you can ask the questions that why do we do this and how it is done. Okay, in fact, at your level I'll not be telling you how it is done. You only need to learn, look at these techniques, and you have to adopt, understand, grasp these skills. Okay, and you will be differentiating the given expressions. Okay, so d by dx, you will see this many a times. D by dt, d by dy, d by dm. So these actually means, this means the derivative of, I'll be writing something here, derivative of, and this dx means with respect to x. This would mean the derivative of whatever there inside the brackets with respect to t. This is going to be differentiation, your derivative, differentiating the given thing with respect to y. This is called differentiating something with respect to m. Now, when we say with respect to m, so what would that mean? You will have to be patient, okay? And you will see that how do we do that, okay? So um, when we, like, the very first technique of the differentiation is, it says the derivative of x raised to power n is n x raised to power n minus 1. Okay, the derivative of x raised to power n with respect to x is going to be nx to the power n minus 1. Or if you differentiate x to the power n with respect to x, you get nx to the power n minus 1. So let me tell you that the derivative of, like when you differentiate, the result is called the derivative, okay? You will be hearing this word a lot, the derivative, okay? The derivative. That derivative is basically the outcome of the differentiation. Okay, so the derivative of, let's say you have to differentiate x squared. So the derivative of x squared is going to be 2x, okay? The derivative of 5x square would be, now this 5x square, so over here when you differentiated x square, this was basically 1x square. So this power is actually multiplied with the coefficient. So this is 2 into 1, that is 2, and then you take off 1 from the power. So that is why this becomes 2x. When you're going to differentiate 5x square, you will be multiplying this 2 with the 5. So that would be 10. And x raised to power 2 minus 1. So this will be 10x. Suppose you want to differentiate um, 6x raised to power 4. So the derivative of 6x raised to power 4 is going to be 24x cubed. 24x cubed. Suppose you want to differentiate minus 2x raised to power 5. So this will be minus 10x raised to power 4. Okay. And similarly, suppose you have to differentiate, let's say you have to differentiate 5 over x square. Okay, 5 over x square. Don't worry. Now I should tell you right in the beginning, you should never ever differentiate anything which is there in the denominator. You first bring that up in the numerator. If that is like, in terms of x, since you're differentiating with respect to x, so the term in x should be up here in the numerator. So you will rather write it as 5x to the power minus 2. Okay, so this will become minus 10 x raised to power minus 3. You will further decrease this power by 1. Okay, so this would then become minus 10 over x cubed. Now, suppose you have to differentiate um, 6x and then there is a cube root on it. This power can be anything. This n over here can be any real number over here. Okay, so this is 6x to power 1 over 3. So this would be 6 into 1 over 3 and then x is to power 1 over 3 minus 1. So this is, you can cancel out these two here. This is 2x raised to power minus 2 by 3. That is how you differentiate this, okay? And then some more examples on it before we go further deeper into this. Okay, now suppose you have to differentiate. Let me take some other color on it. Okay, now let's say you want to differentiate um, 6 under root x. Okay, don't worry. You can write it as d by dx of 6x raised to power half. Okay, and now this would be 6 into half and x raised to power half minus 1. Okay, so this is going to be 3x raised to power minus half. You can write it as 3 over x raised to power half or 3 over under root x. So guys, if you look at all these examples that I have shown you while differentiating with respect to x, you see that we have been applying this rule that if you have x raised to power n, so this is n x raised to power n minus 1. Now this power n over here, it can be positive, it can be negative, it can be in decimals, it can be rational, like, this can be anything. So the thing is, whatever expression you have to write that into this form, and then you have to differentiate it. Okay. Now, if you have seen this technique being applied over here, then you can really try the questions like this. Let me give you some more examples here. Now, suppose you have to differentiate, there is 6x cubed minus 5x squared plus 3x plus 2 plus, now this is a bigger expression here. Okay, so you have something like this and you want to differentiate this with respect to x. Okay, now before I differentiate this, I should tell you about this constant over here. Whenever you differentiate a constant with whatever, I mean, with respect to whatever you're differentiating this, so whenever there is a constant, its derivative will always be equal to 0. Why this is 0? Because you can assume that this is, when you're differentiating it, you can assume you have ax raised to 0 with this. So when you do that 0 into this, so everything will become 0. So whenever you differentiate a constant, the derivative of a constant is always 0. Acha. So guys, before you differentiate this, yes, beta? Yes. Is there any question?
Can you please explain this again?
Look at this. This is the number over here. Like suppose you have
Can you please
to differentiate. For example, there's 2 over here. Okay. So when you have to differentiate this with respect to x, so this should be in terms of x. So there is no x over here, but you see you can write 2x raised to 0 with this. And because x raised to 0 is 1. So when you differentiate this, when you apply this technique onto this, that you know that the derivative of x raised to power n is going to be n x raised to power n minus 1. So this n has to be multiplied by the coefficient of this x over here. Similarly, this 0 will be multiplied by this 2. So everything will be 0. Okay, so the derivative of a constant is always 0. Is that clear, beta? Hmm?
Yes, sir.
Okay, beta. Now, before I differentiate this, I should be having all these terms in this form, x raised to power n form. Okay, so I'll be writing this in that form. So this is your 6x cube here. This is minus 5x squared. This is plus 3x. This is plus 2. This would be 9x raised to minus 1. This would be 3x raised to power minus half, and this is minus 4x raised to power 3 by 2. You see, all these terms are in this form, x raised to power n. Now we're ready to differentiate this. Now this differentiation would be distributed inside. So this means all of them, they have d by dx with them. I don't want to write all that step here. So 6x cubes derivative would be 18x squared. Minus 5x square's derivative would be minus 10x. And look at this 3x. What should be the derivative of 3x? If you have this d by dx of, let's say, 2x. So the power is 1 here. So 1 into 2 will give you 2. And what would be the power left on x? That would be 0. Yeah. So that is why this is going to be 2. So similarly, the derivative of 3x would be plus 3. The derivative of this 2 is going to be 0. Okay. And this one is going to be 9 into minus 1 into x raised to power minus 2. This is 3 into minus half and x raised to power minus half minus 1. This is minus 4 into 3 by 2 x raised to power 3 by 2 minus 1. Okay. So okay. अच्छा बच्चों, so this is, let's simplify this a bit. This is going to be 18x squared minus 10x plus 3 minus 9 over x squared minus 3 over 2x raised to power 3 over 2. This is minus 6x raised per half, and you can write it as under root x. So this is the derivative of all of it. So I'll keep it up to this. It is your time for you guys to practice the things out now. Okay. So I have the exercise here. So you will now be, it says differentiate with respect to x over here. Okay. So please try the parts from question number 3. And then in the next segment, I'll take you to the question number 4, 5, and 6. Okay, in this third question, before you differentiate, you have to make sure that all your, the given expressions, they should be in the form x raised to power n. So we are fine with A, B, C. This D should be written as x raised to power minus 1 before you differentiate this. You can imagine this is x raised to power 2 by 3, and you're not allowed to go for the products or the quotients, provided you're going to apply the first technique. So this has to be x raised to power 5. You're going to add up the powers. This is x raised to power 3. Okay, now I'll be writing the derivatives in red. So this would be 5x raised to power 4. This would be 9x raised to power 8. This would be minus 4x raised to power minus 5. Okay, this would be minus x raised to power minus 2. And this is going to be 0 here. Okay, this one is going to be 2 by 3. And what is 2 by 3 minus 1? You should be very good at it. That is going to be minus 1 by 3. Okay, so this is going to be the power on this is going to be minus 1 by 3. This one is going to give you 5x raised to power 4. And this one is going to result as 3x squared. Okay, in the next segment, I'll be going on to question number 4, 5, and 6. So stay tuned, be with us. Thank you very much.